So we were in the discussion of this operators in C language. So we discussed all this. So we're done with assignment operator and increment or decrement operations in the last session. So now we'll come across with conditional operator. Okay. So conditional operator. So there is another name for this operator, that is, it is also called as ternary operator. Ternary. So actually, all these operators, the list of all these operators, so this was actually divided into three categories, right? First of all, before going to that operator, I'll let you know. Uh, so what is an operator is, so these are the symbols. So those symbols are used for applying some operations, like say it as a mathematical operation, or it may be a logical operation. Okay, so to do any such kind of operation, though they are called as operators, and on the variables, on the values on which you are applying these operators, they are called as operands. Operand. They are called as sorry, this is operand. Suppose if I say A B, so I'm applying an operator plus. So this plus symbol is the operator, and A and B are called as operands. A and B are called as operands, and this plus symbol is the operator. Okay. So operators are the symbols. Operands are the values on which you are applying the operators, on which the operator is applicable. That is called as operand. Okay. Now all these operators, they are classified in different categories based on the number of operands you can use. To apply one operator, how many operands you basically require. On that basis, these operators, they got classified as unary operator, binary operator, and ternary operator. These operators are called as unary operator, binary operator, and ternary operator. Unary operator means to apply that operator, one operand is enough. To apply that operator, one operand is enough. Like any example for such kind of operator, unary operator? I'll say increment or decrement operators. So how we write increment or decrement? We write a plus plus or minus minus b. That means to do that operation, one operand is enough, right? Those operators are called as unary operators. Okay, those operators are called as unary operators. That means to apply that operator, that's one operand is fine, that is enough. Next, binary operator. So binary operator means to do or to perform that operation, to apply that operator, you require at least two operands. Two operands. Unary means one, binary means two, ternary means three. The number of operands. If the number of operand is one, it is unary. If the number of operands are two, it is binary operator. If the number of operands are three, that is a ternary operator. So any examples for binary operator?
A plus B.
A plus B, A less than B. Okay, all these are, that means your all arithmetic operations, your all relational operators, your all logical operator, not logical all, only logical and logical or. Because logical not will write like this, not A, that means only one operand is enough. So logical not will come under unary operator again. We'll write not A. Whereas for logical N, we'll write X and Y. Right. Again, this is a binary operator. So all arithmetic operators, all relational operators, and logical and logical or, these all are binary operators. That means to perform one operation, you require two operands. Okay, and the next one is ternary operator. So in this ternary operator, to apply this operator, you require minimum three operands. Minimum three operands are used for applying ternary operator. And this conditional operator, which we are going to discuss now, is an example for ternary operator. This is an example for ternary operator. So this ternary operator, it uses two symbols. It uses these two symbols, that is question mark and colon. These are the two symbols that are used in conditional operator. And this expression 1, expression 2, and expression 3. Okay, these are the operands. Question mark and colon are the operator. Expression 1, expression 2, and expression 3 are the operands. Okay, now I'll tell you how this conditional operator works. Okay, now we'll see how this conditional operator works. So it is like this, right? Expression 1, question mark, expression 2, colon, expression 3. So it is like this, right? So see how it evaluates, how this executes. So first, out of these three operands, first it evaluates this expression. So there you can write any expression like A plus B or A greater than B or A less than B. You can write any operation you can write. That is expression 1. Okay. So first it will find out the value of this expression. The value of this expression, it is considered either true or false. The value of this expression is considered as true or false. Okay, when it is considered as true or false, when this is true, okay, so this expression, it might be considered as true or false. If this expression 1 is true, it will go and execute expression 2. If expression 1 is true, then it executes expression 2. If expression 1 is false, in that case it will execute expression 3. That means out of expression 2 and 3, either of those two, any one of them will get executed. Either it will execute either expression 2 or it executes expression 3, but never both of them will execute. Both will never and ever gets executed. Any one of them will get executed. Okay, because your expression 1 answer is either true or false. Sir, if it is a plus b, how can I consider true or false? If it is a greater than b, the result is true or false. If it is a plus b, in that case, only the value 0 is considered as false. The value 0 is considered as false. Any non-zero is considered as a true. Any non-zero is considered as a true, and 0 is considered as false. Okay, so when this is true, it executes expression 2. If this is false, it executes expression. I told you already, either 2 or 3 will execute, never both of them. Never both of them. If it is true, expression 2. If it is false, expression 3. Clear?
Yes, sir.
See, I have two variables, x and y. This x and y are filled with some values. I don't know what are the values actually. Okay, I have two variables, and out of those two, I have two values. Now, I want to find out the biggest among those two. I want to find out the biggest number, either x or big, either x is big or y is big, right? Any one of them will be big. So I want to find out whether which one is big. Okay, so I'll write it like this. See, x greater than y. So this is my first expression. Okay, question mark. If x greater than y condition is true, let us assume, let us assume x greater than y, this condition is true. That means x is having the biggest value than y. Then what we should write in the place of this expression 2? Which one is biggest when this is true?
X.
X is biggest. X. If the condition x greater than y is false, who is biggest?
Y.
Y is biggest. So I will take a variable, say it as big. So now this big is assigned with any of these values, either x or y. That is filled. That will be, this big is assigned with any of these values, either x or y. Okay, see, let us take some random values of x and y. If x value is 10 and y value is 11, so it verifies 10 greater than 11. True or false?
False.
It is false. So when this is false, which will be considered? The second part.
Expression 3.
That means
Expression
it
3.
will, expression 3 is considered. It will simply ignore the part of this x and y. So that is assigned to this variable big. That is assigned to this variable big. Suppose if your values are like this, say it as 10 and 7. Okay. So in that case, what it will do? It verifies like this: 10 greater than 7. This condition
It's
is true or
true.
false?
True.
This is true. So then when it is true, it will consider this part. That
Expression
means
2.
expression 2. So that will be assigned to big.
Big.
So now your big, ultimately you have a variable called big. I want to fill up this variable big with the biggest value of this x and y. So I don't know which variable to assign. Depending on the values of those variables, I will assign this big. If that condition x greater than y satisfies, I'll fill big with x. If that condition fails, I'll fill big with y. Simple. Got it?
Yes, sir.
So I'll write up like this. Uh, A is equal to 5, B equal to 2. So what is the value of result? Amma? Hello? What is the value of result? So what it will do here?
It's 7, sir. It's true.
This is true. So that is 5 plus 2. 5 plus 2 is 7. So 7 is considered as
True.
true case. So when it is true, this is executed, and that is assigned to result. So
Result.
what is the value of result?
True. Expression
True.
2.
Expression 2. What is the value of result? The value of A is assigned to result.
Okay.
So what is the value of A?
5.
So result is also
5.
assigned with 5. Simple. Got it?
Okay, sir.
So you try up with one. You try for one thing. Okay. So you just try to note down. Uh, I want the difference of two numbers. Let us take it as A, B, or X, Y, whatever you want. You take it as that. Okay. I want the difference of two numbers. So difference of two numbers is never a negative number. Difference of two. I am not saying subtract of x minus y. Okay. So what is the difference between 2 and 5?
3.
It is 3. What is the difference between 5 and 2?
3.
It is also 3. Okay. I want to display this kind of answer. Okay. It may be 2 5 or 5 2. I want the difference of those two numbers.
I took
Okay. Hello. Someone trying to say something. So you try this with the help of this conditional operator. Okay. So well, we'll discuss. Still, if you have doubt, we'll discuss this one later. Okay. This is about conditional operator. And next one is bitwise operator. Bitwise. So this is also a binary operator. Bitwise is also a binary operator. So we have bitwise AND, bitwise OR, bitwise exclusive OR, left shift and right shift. Hello, am I audible?
Yes, sir.
Okay, okay. So these are the 5 bitwise operators. So what this bitwise operator actually means is these operations are performed on the bits. On the bits. What is meant by bit? What is meant
smallest
by bit?
unit of computer.
Amma, some
The smallest unit of computer.
smallest unit of computer memory. Okay, smallest unit of your computer memory. So a bit, what a bit can hold? If there is one bit, what that bit can hold? It can hold either 1 or 0. That's it. That can hold only 1 or 0.
0.
And you are trying to apply this operator these operators on those bits. You are trying to apply these operators on those bits. Okay. Got it? I'll tell you how to apply these things on the bits now. So before starting these uh, bitwise operators, first of all we'll see presentation of your numbers. First of all, you should see the representation. So what representations we have? So that we'll see first. So first we'll see this one. We have we'll discuss about two different representations of numbers. One is decimal representation and the other is binary representation. Okay, decimal representation means uh, base 10. Binary representation means base 2. That means any number can be represented with 10 digits, that is 0 to 9. So that representation is called as decimal representation. So normally we write numbers, right? So that is decimal representation. So there we'll be using 10 digits. So 10 different digits are used for representing the numbers 0 to 9. They are the 10 digits we use. In this case of this binary, only two digits are used for representing the number, that is 0 and 1. Only two digits, that are 0 and 1, are used for
Binary.
yes, only 0 and 1.
Okay.
So now we'll see how numbers are represented in binary and decimal and binary. Suppose if I say number 230, don't take that much big number, I'll take 85. Okay. If I have a number like 85, so is this base 10 or base 2?
Base 10.
This is base 10. The same number with base 10, that can be used, that can be converted into binary. That means this 85 can be represented in terms of ones and zeros. So you people know how to convert it? Anyone knows how to convert a decimal number to binary? Okay, I'll take 85, and this 85 is divided with a 2.
8.5.
What?
No, sir. The wrong answer.
No problem. It will divide 85 with 2. So how many times? 40, 42 times. So 42 times is 84. And the remainder is 1. Again divided with 2. 21 times.
21.
Remainder is
1.
oh 1. 21 2, sir. I can't make you to learn the 2 table now.
210.
Hmm?
210 the 20.
21 twos.
Didn't understand.
Huh? You didn't understand?
42, sir.
You divide the number with 2. So I'm
Why
dividing
is this
42 with 2.
LCM or division?
Not LCM, just division. Just dividing 42 with 2. How many times you can divide it? I can
Two
divide it
times.
for 21 times with 21, and finally the remainder is
0.
0.
Hmm.
Divide 21 with 2 again.
10.
10 times. The remainder is
1.
1.
1.
again divide 10 with 2.
5.
10.
5 times. Remainder is
0.
5.
0.
0. Confused.
2 times. Remainder is
1.
1.
still I can divide. 1 time. Remainder is
0.
0. I can't divide 1 with 1 further. Right? So I'll stop it. So after that, you just represent these numbers in this order. That means 1 0, 1 0, 1 0. This is the binary representation of 85. 1 0, 1 0, 1 0, 1. This is the binary representation of 1. Got it? Nothing.
Yes,
You are
sir.
simply
Like
dividing it with 2.
division.
Okay.
I didn't get you. Hello? You're trying to tell something?
No, sir.
So simply whatever number you want to convert, you start dividing that number with 2 and consider the reminders. Okay, when you are dividing with 2, your reminders may be 0 or 1. So you will get only these two. So collect all the reminders and place those reminders in the reverse order. That means start from this point and write in continuous order like this. Okay, so that is the binary equivalent representation of 85. So that means 85 base 10, that is represented as 101010 base 2. Both are same. So one is decimal representation and the other is binary representation. That's it. Got it?
Yes, sir.
Hmm.
Yes, sir.
So next, I'll take simple exam. One more example, and I'll again tell you how to convert a binary number to decimal also. Okay, I'll take 15 basis of base 10. Okay, so I have 15. So I'm dividing this 15 with 2. So 7 times, a remainder is 1. So 2, 3 times, a remainder is 1. So 2, 1 time, and again remainder is also 1. So that means all 4
Zero.
ones.
Yep.
Sorry, this is the decimal representation for 15. So this is how you can convert your decimal number to binary. Okay. So I will show you how to convert a binary number to decimal. How to convert a binary number to decimal. So I'll take a number like this. Say 10 days to. So what is the a decimal equivalent of this? So I want to give the decimal equivalent of this. So what you can do is see 1010. Okay. So here I'll take, you take just powers of 2. So 2 power 0, 2 power 1, 2 square, 2 cube. If you have some other numbers here, I'll take 2 power 4, 2 power 5, 2 power 6. I'll go on like that. Okay. First 2 power 0 into 0, or you can write 0 into 2 power 0 plus, next consider this term 1 into 2 power 1 plus, next this term 0 into 2 square plus 1 into 2 cube. You just find the sum of this, that is the decimal equivalent of this. So 0 into, so whatever it is 0. 1 into 2 power 1, 2. 0 into, this term is also 0 plus 1 into 2
8.
cube. So for decimal number 10, the binary equivalent is this one, 1010. Okay, you can take 10 and you can convert it into this also. So 5 times 0, 2 times, sorry, 2, 2 times 1, when again divide with 2. 1 time, remainder is 0, and this is a representation 1010. So both got tallied, right?
Yes, sir.
So this is how you convert a binary number to decimal and decimal number to binary. Okay. So you tell me the decimal equivalent for 0101. So what is the decimal equivalent of this number 0101? Hello.
Then should we solve this?
5.
Hmm. Yes, yes. I'm asking decimal equivalent for 0101.
5.
Simple it is 5 because it is 2 power 0. So anyhow 2 power 1 is 0. So I don't mind it. So next 2 square. So 2 square is 4. 2 power 0 is 1. That's it. So clear about this now?
Yes, sir.
So now our task is this this bitwise operators are applicable on those binary values. Okay. So every number you give that is converted into binary format, and on that binary number these operators are applied. These operators are applied. They are not applied directly on the numbers, on the decimal representation numbers. The things which we have seen till now are applicable on decimal representations. I write a plus b, a and b are decimal integers. Okay, even though I give an integer value here, that is not, these operators are not applied on decimal representation. Got it? So first one is bitwise end. So in this bitwise end, so what happens is, suppose I say, uh, I'll not write it here, I'll directly write it in the notepad. Okay, so I'll take bit 1, bit 2, and bit 1 and bit 2. Okay, so if I say bit, either it is 1 or 0, that's it. If bit 1 is 1 and this is also 1, so different combinations I am taking: 1, 0, 0, 1, and if both are zeros, so when this end operation will result to 1 and when the end operation results to 0, if both the bits are 1, then only it is 1. If any one of them is 0, that is 0. This is what we seen in the logical end also. In logical end also, if both the operators, both the expressions gives you 1, that means if both of them are true, it is true. If any one of them becomes false, that is false. That is the same story with the end operation, bitwise end operation also. So just I'll take just the two numbers and I'll apply all the operators on those two numbers only. Okay, no. I'll say A and B. Okay. So what is the value of A? I'll take we'll take the value of A as 5 and B as 7. Okay. So what is the binary representation of A and what is the decimal, sorry, binary representation of B? What is the representation of 5 in binary format?
10.
Binary representation of 1, sorry, 5.
0, 1, 0, 1.
That is 1 0.
Sorry, sorry.
You can write 0 1 0 1 or 1 0 1, anything fine, no problem. Okay. So what is the binary representation of 7? It is 110. Okay, you can place zeros here, no problem, because and generally we represent anything at least minimum with 4, then 8, then multiples of 8. Okay, any binary representation we generally start with minimum with 4 bits. We call these 4 bits as nibble.
So how can we find the binary of these two numbers of any number?
What?
So how can we find a binary number of these two of any number?
That is what I told previously. How to convert 5 to decimal. Sorry, how to 5 to binary.
So sir, that is the trick to find
That is the
trick to find it.
we have to follow that procedure. Divide with 2. You consider all the reminders and place the reminders in that order. You will get the binary representation of any decimal number.
Okay, sir.
So with that format you apply, you will get the binary representation of 5 and 7 like this. Okay, when I write A and B, when it is A and B, it is like this: 0 1 0 1, and B is 0 1 1 0. So if you apply A and B, what is the result of this? 1 0. So what is the result of 1 0? You can look at the table and you can see
0,
1 0 is 0, 0 1,
0,
1 1,
1,
0 0.
0.
So what is the decimal number of this 0 1 0 0? That is 4.
4. So,
Yes, yes.
sir, I wanted to ask how is B0110? It should be 0111 now. Hello, sir.
Uh, yes, yes,
How is
yes, yes,
B0110? It
yes,
should
yes,
be
yes. You are right. You are right. Actually, it is actually the representation of 6, not 7. I'm sorry. Thank you. It is 0 triple 1, 0 1 1 1. So everything will changes here. So this is also 1. So and the result is also
Answer is 5.
huh? A and B is 0
5.
1 0 1. So which is the representation for
5.
5. Okay. So this is how you can apply bitwise end operation. Okay. So in the same way we have one more which is bitwise OR operation. So that is B1 or B2. Sorry, it is not 2 symbols, it is only 1. If it is 2 symbols, it again becomes a logical OR, not bitwise OR. So it is like this: B1 or B2. So for B1 or B2, again we'll have a combination of 1 1, 1 0, 0 1, 0 0. In the case of this bitwise OR operation, either of if any one of the bit is 1, the result is 1. If both are 0, then only the result becomes 0. If any one of the bit is 1, the result becomes 1. If both the bits are 0, then it is 0. Okay, so any one bit is enough. So then it automatically it becomes 1. See, if you take it here like this, A or B. So here again I'm taking the same numbers. I'm not changing the values. So you just try for some numbers. Okay. So 0, 1, 0, 1. That means here I'm writing I'm considering it as A or B. So this is A and this is B. 0, 1, 1. So now what is the value of A or B? What is the value of this?
0 1
Zero
1.
triple one.
It is simply 0, 1, 1, 1. Okay. So now this is a representation
7.
for 7.
7.
Okay. So these are the two bitwise operators. So we have one more bitwise operator, that is bitwise exclusive OR. This is OR and that is bitwise exclusive OR. So this is represented with this cap symbol. So you can see that cap symbol on your keyboard and the number 6. Okay. So when you are applying this bitwise OR operation, uh, yes, in bitwise exclusive OR, that is we call it as XOR or exclusive OR, anything is fine. Okay. So in this, here also you will have the combinations of this. Which combinations? B1 XOR B2. Okay. In this case, the result of this operator is 1 if both the operators, if both the bits are opposite. If both the bits are in opposite one, that is 1 0 or 0 1, in that case you will get 1. Otherwise you will get 0. That means if both are ones or both are zeros, the result is 0. If both the bits are opposite to each other, that means 1 0 or 0 1. So for that combination you will get 1. If both the bits are zeros or if both the bits are ones, you will get 0. A X or B. So again I'll take 0 1 0 1 and here it is 0 triple 1. So what is the value of this operation now?
0010.
So here both are ones. So it is
0.
0. Here
0 1
the bits
0.
are opposite.
1.
0
1
1 0 1.
0
0. 0.
0.
And this is also. So what is the representation of this? For which number it is 0010?
2.
Yes. That means 5 XOR 7. So that will result you 2. So if you simply look at that 5 and 7, 5 or 7, uh, you can't guess the. So why you are getting these numbers? So we are getting these numbers because the operations are performed on the bits. So this directly it converts the numbers into bits. The operator is applied on those bits, and the resultant binary representation is again converted into decimal, and that is the answer. That is your result. When I apply A and B, it will not give me 0 1 0 1. It will give me only then when you write in a program, it can give me 5 directly. That means conversion from decimal to binary and conversion from binary to decimal. So both the things will happen internally. We are applying on the decimal numbers, and it is giving the result is also decimal representation. So we have two more bitwise operators to discuss. Left shift and right shift. So we'll see them in the next session. Okay. So this is for today's. So hope you understood everything. So if you have any doubts, you can just clarify now. So any doubts?
Clear, sir. Thank you.
Yes, sir. Thank you. Thank you very much.
Thank you.
Thank you, sir.
Okay, Nana. Thank you, everyone. Have a nice Sunday. So we'll meet on Monday again.
Yeah. Okay,
Okay,
sir.
sir. So we
Chalo.
don't have class on Sunday.
No, 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 no class on Sundays.
Same next school.
Enjoy on Sunday.
Okay, sir. Thank
Sunday.
you.
Okay, sir. Thank you.
Actually, we have a holiday on Saturday also, but yesterday due to heavy rain here, so I stuck up at some place. So I couldn't able to take the session. So that is why I've taken extra for you to cover yesterday's.
Okay, sir. Thank you.
Okay, sir. Thank you.
Thank you. Happy Sunday. Sir, Rajesh sir.